All right, well, let's get started and we'll do a slow start in for anyone who's running a little bit late. But hello, good morning, good afternoon, good evening, wherever you are. Thank you so much for joining us today. My name is Celeste Stewart. I'm the Patient Engagement Manager for the National Ataxia Foundation. And it is my pleasure to be introducing our speaker today for this talk all about SCA1. Before we jump into that though, just a few housekeeping items. So first, if you need closed captioning, you can turn it on at the bottom of your screen by clicking the button that has the CC on it in your menu. So if you click that, you can turn on closed captioning. Also, please feel free to chat with other attendees using the chat feature like we just did now to say where you're coming from. So if you want to chat with others who are on this call, please feel free to use the chat. If you have any questions for our speaker, though, we ask that you please use the Q&A function that you can also find at the bottom of your screen on Zoom. So you can ask questions at any time throughout the talk. So if you see something and you have a question about it, please feel free to drop it in the Q&A window. And then we'll collect all of those questions until the very end of the talk, and then we'll be able to chat more about them. And yes, you'll want to keep your microphones off and your video turned off, just because we have a lot of people on the call with us today. And if microphones are turning on and off, we get a lot of background noise. So we appreciate you keeping your microphones off and your cameras off as well. But without further ado, it is my absolute pleasure to introduce our speaker today, Dr. Sharan Srinivasan, MD, PhD. He is currently a clinical instructor in the Department of Neurology and Movement Disorder Division at the University of Michigan. He obtained his bachelor's degree from Northwestern University and his MD and PhD degrees from the University of Michigan, where he also finished his residency in general neurology. He completed his movement disorders fellowship focused on ataxia at Mass General Brigham, Harvard, before returning to the University of Michigan. Clinically, Dr. Srinivasan is dedicated to the care of ataxia patients with a focus on hereditary degenerative diseases. He also has a dedicated research program developing and discovering novel therapeutics for Spinocerebellar Ataxias and other related cerebellar disorders. So thank you so much for joining us today. The floor is yours.
Thank you, Celeste, for that introduction. That was wonderful. And thank you to the National Ataxia Foundation for giving me this opportunity to speak about Spinocerebellar Ataxia type 1 or SCA1 or SCA1. You'll probably hear me bounce around between all three of those pronunciations. So I was tasked with talking about the clinical presentation and management of SCA1. But I will do a little bit of discussion about research, but there is going to be a talk given next week, I believe, on the research and management and study of SCA1. So if you have specific questions about research, that would be a great talk to attend. Let's see if this goes. Here we go. Just some disclosures. I don't have any financial disclosures, but I want to let you know I spend most of my time in the basic science world discovering and developing therapeutics, or attempting to, for SCA1 and some of the other hereditary ataxias. But I do spend a decent chunk of my time seeing our SCA patients and other ataxia patients in our clinic here at the University of Michigan. Okay. So I wanted to talk a little bit at the beginning about how this disease and this entity really kind of came to be understood as its own disease. Ataxia as a clinical symptom has actually been recognized since the mid-19th century. And even back then, it was understood that there were a group of these disorders that they thought, eventually became termed the Spinocerebellar Ataxias. And many of them were studied and described extensively during that period. But it wasn't until really the late 20th century when we started having advances in genetic technology that we had the ability to understand the cause of these diseases. And so in the early 1990s, there were two large families, one from Minnesota and one from Texas, that were described to have ataxia, ophthalmoparesis, or difficulty with eye movements, and motor weakness, and had very similar clinical presentation. And on imaging and autopsy pathology, they had degeneration of neurons in a part of the brain called the cerebellum and another part called the brainstem. And in the early 1990s, this disease was mapped using an old genetic technology called linkage mapping to the 6th chromosome. And in 1993, the gene causing SCA1, which is called the Ataxin-1 gene, was cloned, and the investigators cloned and discovered the CAG repeat that drives the disease. And so this was really a monumental and pioneering effort led by Harry Orr at the University of Minnesota and Huda Zogby down at Baylor College of Medicine in Texas. And a tremendous amount of work has been done since that time, some of which I will talk about today. So I wanted to talk about the prevalence and epidemiology, and this is a global disease. And on the top right, you'll recognize that this is a pretty rare disease. And for those of us in the ataxia community, I feel like I can't get enough of seeing SCA1, and I see it wherever I go. But in reality, it's about 1 or 2 people per 100,000 folks who have this disease. And looking at this map, you'll see as you move from green to red, the prevalence increases. So in Russia, South Africa, Poland in particular, are very high concentrations of SCA1 patients. This slide's a little outdated, but then in Japan and India, we start seeing a very large percentage of SCA1 as well. And even though the gene was discovered here in the United States, prevalence in the US and North America and Brazil and most of Western Europe is actually relatively low. So a little bit of a crash course in the genetics driving this disease. Each one of us has about 20,000 genes in our body. And for each of those genes, we have 2 copies, one from mom and one from dad. And in some diseases, you need 1 copy of those disease to go wrong or get changed in order to have the disease. And in other diseases, you need both copies to be affected. And so in SCA1, we characterize it as an autosomal dominant disease because you only need 1 affected copy of the gene to become changed or mutated in order to inherit it. So if you look at this figure here on the right, you'll see that the blue gentleman here, the affected father, has a mutated copy of the Ataxin-1 gene, and so he has SCA1. The mother of this family does not have either or both copies of her Ataxin-1 gene are normal, and so she is unaffected. And because the mother only has normal copies, she can only give a normal copy to her children. So she gives 1 of her 2 normal copies to the children. So every child has 1 normal copy. And the father has 2 choices, even though it's not his choice, but to give either a normal copy or a mutated copy of his Ataxin-1 gene. And so it's literally a coin flip, a 50-50 chance that his children will get the mutated copy and therefore inherit SCA1, or his normal copy and be unaffected. So anyone with a 1st-degree relative of SCA1 has a 50% chance of inheriting that gene and developing the disease as well. There's also a phenomenon that this disease demonstrates, which is called anticipation. And I'll explain the genetics of that in the next slide. But what that really means is that from generation to generation, the disease tends to accelerate. And so the children of affected parents tend to be affected earlier and are more severely affected than their parents. So SCA1 is one of these CAG repeat expansion diseases. And so in our DNA, all of our genes are made up of 4 letters, A, C, G, and T. And they occur in various permutations across billions of letters that make up who we are. And within the ataxin gene and several other genes, there is this CAG, CAG, CAG repeat region. And every one of us has this repeat. And CAG gets transcribed into a form of a molecule called RNA, which still has a CAG, which gets made into a protein. And the building blocks of proteins are these molecules called amino acids. And CAG encodes for an amino acid called glutamine, and the letter for that is Q. And so oftentimes you'll hear these diseases like SCA1 called poly-Q diseases or polyglutamine diseases. And you'll see here is that these poly-Q or polyglutamine proteins can have numerous complications in how a cell functions, and those cellular abnormalities lead to the clinical symptoms in our patient. And so when we are analyzing patients, what we honestly do is we sequence their gene, and then we count how many times does this CAG trinucleotide repeat, and we count what is your repeat number. And you'll hear many neurologists and researchers ask, what's the repeat number? And what's very clear is that there's a pretty good cutoff. And so if your repeat number is below 35, you're healthy. You're not going to develop this disease. On the flip side, if your repeat number is 45 or greater, you are almost certainly going to develop SCA1. Exactly when that will develop is not entirely clear to us. You'll notice this middle row here between 36 and 44 repeats, where I've labeled the status as intermediate. And you could also call that indeterminate. And that's because whether or not a person is going to develop SCA1 with a repeat number in that range depends on some other factors. And that depends on factors within the ataxin-1 gene and factors outside of the ataxin-1 gene too. So some of our intermediate or indeterminate patients never develop symptoms. Some of them develop symptoms exactly the same as an SCA1 patient. And sometimes patients will demonstrate incomplete penetrance or some of the symptoms, but not all of them that our SCA1 patients do. What is clear to us, though, is that the larger the repeat number, or the CAG expansion, the younger patients present with symptoms. So following this graph on the x-axis down here is how many symptoms, how many CAG repeats they have. And as we go up on the x-axis, the age of onset here on the y-axis drops down fairly dramatically. And not only do you present earlier in life, but typically the course is much more aggressive and symptoms will develop more rapidly. Discussing clinical symptoms. So, the classical age of onset for SCA1 is somebody in their 30s or 40s with gradual slow progression over time. And there's always exceptions and outliers who, like I just said, if you have a low repeat number, you might develop symptoms much later in life, or if you have a higher repeat number, even earlier in life. When I consult patients on their ataxia symptoms, one of the ways I describe it is the cerebellum, which is our coordination center of our brain, and the part of the brain that's most affected by these hereditary ataxias, does a lot of things. It coordinates movements in our arms and in our legs. So many times people have difficulty walking in poor balance. Many times they have difficulty with fine motor skills and the lack of coordination driven by the cerebellum. But it also coordinates our speech and how accurate are the rate of our speech is, the rhythm of our speech, the volume of our speech. And so sometimes that gets affected in our patients. The cerebellum helps coordinate our eye movements. So how accurate your eyes move, whether or not many people develop this phenomenon called nystagmus, which is when their eyes bounce a little bit. And those can be very disrupting to patients' quality of life. The cerebellum coordinates our swallowing. So making sure that food goes from the top of your esophagus or your swallowing tube down to the bottom. And if that gets impacted, then people have difficulty swallowing and are at high risk of aspiration. And that can be a major cause of mortality in our SCA patients. And then something that I think is really important to highlight is that the cerebellum and the brain have a role in coordinating many components of our body that we don't think about. So I've listed heart problems here, but it's your heart rate, your blood pressure, your bladder function. And so many patients with SCA1, as well as other hereditary ataxias, have difficulty with things that we call our autonomic nervous system, which means the part of your brain that you don't think about. The part of the brain, the part of your body that is controlled by your brain without you having to think about it. And so it's really important. I spend a lot of time talking with my patients about how this isn't just a motor disease. In SCA1, later on, we start seeing cognitive deficits. And so I spend a lot of time discussing with them, what are the things on a day-to-day basis that bother you? Because some of these things we actually have treatment for, and some of these difficulties and symptoms, we can make major impacts to patients' quality of life. So if you're not hearing about these questions, then please feel empowered to ask your physician and ask about whether there are things they can do for some of these symptoms. And when you see your neurologist, when I first see an ataxia patient or somebody who's coming to me with a concern of ataxia, by far and away, the most important thing is to take a detailed clinical history, asking when your symptoms started, how old were you, what was the first thing that you've noticed, do you think things came on rapidly or were they slower? How have things progressed over the years? Have you plateaued? Have you gotten worse? Have you gotten better? Doing a really detailed family history. What about your siblings? What about your father, your mother, your grandparents? Tell us about aunts and uncles. Tell us about cousins. In ataxia, it's sometimes difficult because our clinical diagnosis of many of these diseases has been more recent. So many of my patients' family members were diagnosed with another neurodegenerative disease, for example, Parkinson's disease. And we realized later, only after diagnosing their children, that that person actually had SCA1, for example. All of my patients get a very detailed neurological examination. The first time that I meet them, I do a very thorough head to toe, examining cognition, their eye movements, listening to their speech, feeling their arms and their legs, looking at their eye movements, watching them walk, examining their coordination. And you can get a good idea of what's affecting the patient, and then a review of their labs and their imaging. And it's here when we look at the imaging, and this is an SCA1 patient who I believe was 62 years old. And I wanted to point a few things out here, which is that on the left, these are 3 different views of a person's brain. And on the left in panel that's labeled A, the person is looked at in profile. So you're looking at them from their side. So you can hopefully appreciate their noses here. This is the top of their head, the back of their head. This is their spinal column going up. And this thin gray line here that my mouse is tracking is their spinal cord going up into their brain stem. Here is the top part of the brain, or the cerebral cortex. And then this back bottom part is the cerebellum that I've been talking about. And I didn't put a healthy person's brain for comparison, but what I want to say is that the cerebellum here looks a little bit small. It should be filling up more of this empty black space. And similarly, the brainstem here starts showing some thinning. So instead of being very plump and bulbous almost, it's actually quite narrow and straight. And when we look at in panel B and C, we're looking at patients from slightly different views. So in panel B, we're looking at their face head on. And when we scroll through the back, we actually can start appreciating that even though the cerebellum's not filling either all of this black space, neither is the cortex. And actually later in life and later in this disease, we start seeing degeneration of parts of the brain that are outside of the cerebellum. And in here, it's the cerebral cortex. And we think to some extent, this contributes to the cognitive symptoms that we see in SCA1. And now in panel C, we're looking at a patient basically head down. So if we're taking cross sections of their brain parallel to the ground as they're standing, and what you can see here is their eyes. This is the patient's nose. And what is this arrow here is pointing to basically a white cross that exists in one part of the brainstem called the pons. And that's actually in neurology known as a hot cross bun sign, which takes from the British delicious pastry that's made during the Easter holidays. And that abnormality used to be very tightly and still remains very tightly associated with another disease called multiple system atrophy. And before the emergence of genetic technologies and sequencing, many of our SCA patients were actually improperly diagnosed with MSA based on this imaging characteristic. So I wanted to highlight this to show that it's actually an imaging feature that can be part of many different diseases. And without having definitive genetic testing, there's no definitive answer on whether a person does or does not have the disease. On genetic testing, and this is a question that I spend a lot of time talking with patients about and family members about, and I expect many of you listening to this may have questions about, should you get tested? When do I get tested? How do I get tested? I've listed 3 categories for major indications to get genetic testing. And the first would be that if you have ataxia-related symptoms and a known family history of SCA1, meaning that there is a first-degree relative with SCA1. Second category is you have a first-degree relative with SCA1, but you don't have symptoms yet. It means that you're at 50% chance of having the disease, but 50% chance of not having the disease. The third category of patients are actually one of the most common, which is patients who present to me with an adult onset ataxia, meaning that they developed ataxia or trouble with their coordination in their adult years, but there's no clear family history or a slightly confusing family history. The example I gave earlier was that somebody whose father or grandfather had Parkinson's disease, and it may be that father or grandfather did have Parkinson's disease, but it may be that they actually had SCA1. And if I look at a patient clinically and I think that they fit the clinical presentation for SCA1 or another SCA, I will usually opt to proceed with genetic testing. Genetic testing is not something to be taken lightly, and I'm not a licensed genetic counselor, and I strongly encourage, if you are thinking of getting genetic testing, to seek guidance with a genetic counselor. But a few things that I'll simply say, which is there is the Genetic Information Non-Discrimination Act. And what that means is that this is a law to protect you as patients from being discriminated based on the genetic information in your body. That means nobody can use your genetic information to discriminate you for hiring for a job, for firing you, for promotion, or even for health insurance. However, it does not protect against long-term care, long-term disability, or life insurance. And I make sure patients who are undergoing genetic testing understand that and know that law, because for patients who don't have life insurance, sometimes it's best to get life insurance before you proceed with your genetic testing. It's also really important to understand that there are equal reasons to not get tested and to think about what would you do with the information once you receive testing. Would this change how I go about my life? Would this change how I interact with my family? What would I tell my children with a positive result? What would I tell my positive sibling if I have a negative result? So these are all really important factors to think about when you're pursuing or thinking about genetic testing. And here I get to put a plug for how do I get genetic testing? And here's a plug for the NAF, or the National Ataxia Foundation's no-cost genetic counseling and testing initiative for SCAs 1, 2, and 3. And what this means is that if you are at risk for SCA1 in particular here, because you have a family member with a confirmed genetic diagnosis, that you are eligible for free virtual genetic counseling and then coordinated genetic testing. And this will be done free of cost to you. You simply have to live in the United States and be 18 years of older. And this is a wonderful resource that I direct actually almost all of my genetic testing patients for who have SCAs 1, 2, or 3 in their family. It's actually quite quick and much easier to logistically coordinate than working with third-party vendors. That being said, there are many third-party companies that do genetic testing. Many of them these days are working increasingly more with insurance companies to provide these resources at an affordable cost to patients. That being said, more comprehensive testing is still expensive and typically difficult for many patients to pay for out of pocket. All right. So one of the unfortunate things is sitting here right now, whoops, I'm sorry. There is no definitive cure for SCA1. We have many studies that I will talk about in the coming slides, but a large portion of my care as a neurologist is trying to work on the symptoms that afflict our patients and work with them to try and improve their quality of life. And so there are some medications that we do use that can sometimes help with episodes of ataxia. And they're listed here: acetazolamide, 4-aminopyridine. Dalfampridine recently became generic. It was used to be a medication strictly for use in multiple sclerosis, but does have some efficacy in certain ataxia conditions. And then a combination of 2 muscle relaxants called baclofen or chlorzoxazone. vertigo, or the sensation of movement when you are not moving, or dizziness in general, is probably one of the symptoms neurologists hate the most because it's extremely difficult to treat and it's very debilitating for patients. Oftentimes, antihistamines, meclizine or diphenhydramine or Benadryl can be helpful, but personally, I find them to be quite sedating for my patients and they're very difficult to tolerate. Gabapentin can be sometimes helpful, and a low dose of clonazepam, which is a benzodiazepine, a longer acting one, can sometimes help my patients as well. But this is really a tough symptom to treat, and I hope that we come up with better options in the future. I reference things like nystagmus, which means bouncing eyes, and sometimes that contributes to people's dizziness and vertigo. Sometimes it contributes to their ataxia itself. And so again, there are a couple of medications that we have anecdotally found in the clinical world to be helpful for certain patients. And same thing with the muscle cramps and the muscle relaxants that we use. And in general, what I would say is that there's no perfect algorithm for these medications and for clinical care of SCA1. Many of our patients will respond to these medications and many of them will not. And it's unfortunately a little bit of trial and error. So I ask patients to bear with me because sometimes we'll try one medication and it may not work at all. And other times it may have side effects. Even if it does work a little bit, then the side effects are worse than the symptoms itself. And so it can be a little bit of time and trial and error and commitment on both the part of the patient and the physician to really find a regimen that can be helpful. But that leads me to talk about kind of the 4 cornerstones of treatment for SCA1, which is really about prevention and management. And that's working with a physical therapist or a PT, helping with things about gait, balance, mobility, finding the correct assistive device for you. I can't tell you how many patients will come and say, I tried physical therapy, it didn't work. One of the important things is to find a physical therapist who is familiar with neurological diseases and ideally with ataxia, because the exercises for an ataxia patient are different than the exercises for a Parkinson patient or for someone who's just had a stroke. Last week in clinic was a gentleman who insisted that his walker wasn't helpful. And then I had him see physical therapy and she offered him a different walker and his walking's greatly improved. Occupational therapy or OTs can help in preventing issues at home regarding home safety. So our occupational therapists will do home safety inspections to make sure that there's shower rods installed in showers, that rugs are pulled off of floors to reduce tripping, that there's pads in the house with furniture or walls to grab onto, helping with hand coordination or exercises to improve dexterity. Speech language pathology or SLP are a tremendous resource. I told you that difficulty swallowing or risk of aspiration is one of the leading causes of mortality in this disease. And so it's really important early on when I hear somebody's coughing on food or water or choking, that they're seen by a speech language pathologist to evaluate their swallowing, sometimes doing what's called a swallow study of drinking some barium contrast to make sure they are not aspirating. And then there are techniques and recommendations to improve safety of swallowing and reduce the risk of aspiration. Speech language pathologists also work closely with speech therapists to help improve clarity, improve enunciation, and make it easier to be understood. And by far away, the single best thing you can do for yourself as a person with any type of ataxia is to exercise. I encourage any patient of mine to do robust cardiovascular exercise. My sort of canned line is about 20 to 30 minutes a day, 5-6 days a week, something that gets your heart rate up, something that gets your blood pumping, breaks you into a light sweat. And then there are 2 additional exercises, yoga and Tai Chi, that have been clinically shown to improve balance in patients. And actually, I believe later this month, there's going to be a webinar on adaptive Tai Chi for ataxia. So I'm looking forward to that talk actually to see if I can learn some techniques for my patients. But I encourage all of my patients to start with some simple yoga, building in that stretching and flexibility and working on a different set of muscles. I recently discovered the Ataxia Marketplace at the NAF website. So I would strongly recommend taking a look here if you have not done so already. This was a website put together with a group called Day Undefined, identifying sort of life hacking ataxia. So devices and adaptive tools to help you with kitchen and drinking and home technology or shoes or household items that can really make a difference on your day-to-day basis. There's no vested commercial interest here. This is simply for the purpose of helping people find devices to make their lives easier. So I encourage you all to take a look. It's really an amazing resource. So what's next for SCA1? You know, I've talked about the clinical overview and what we as clinicians are able to perform and provide for our patients. But I really think that basic science discoveries are going to drive our new therapeutics in the next era of ataxia. And so this is a complicated slide with a lot going on, but what I want to highlight is that even though this is a genetic disease, a change in a single gene, is that there are alterations or problems in how a cell and how the brain operates in a variety of ways, whether that's ion channel activity, changes to the proteins that are encoded for by genes, synaptic or neuron or brain cell to brain cell communication, how proteins are handled, and even how blood vessels form and supply blood to the brain. And each of these areas represents a target for potential pharmacologic or therapeutic intervention. And rightfully so, a majority of the effort has focused around the root cause, which is this genetic change. And so again, a complicated slide. What I want to highlight is that this is work done in a mouse model of SCA1. So this is literally a lab mouse that contains a genetic expansion in the ataxin-1 gene, mimicking the human disease. And here we're testing the effects of a gene targeting strategy against the ataxin-1 gene and measuring its effect on how a mouse performs. And so in these top row, there are three colors here that you should look for. And so the green is a healthy, normal mouse. And orange is that SCA1 mouse that has not been treated. And red is an SCA1 mouse that's been treated with this gene therapy. And in this fun experiment, we honestly put these mice on a spinning log called a rotorod, and we see how long it takes for them to fall. Or we ask these mice to cross a narrow balance beam, and we ask how long it takes for them to cross. And these are what we call surrogate metrics for measuring ataxia, because we unfortunately can't do as complex neurological exams on our mice as we can on human patients. And the main takeaway here is that gene therapies against ataxin-1 improve the function of an SCA1 mice. And so the red line gets closer to the green than the orange line. Importantly here is that it actually improves survival. And so this yellow, orange, and the blue lines are these SCA1 mice that are untreated that pass away much quicker than our green healthy mice. And the red line extends survival over time. And very similar work has been done in SCA3 mouse models. And so there's a gene-targeted strategy against the ataxin-3 gene, which is the gene causing SCA3. And it resulted in our blue line, which is the SCA3 mouse getting treated, becoming closer to the black line, which is our healthy wild-type mouse, compared to an untreated SCA3 red line. And because of this work, there is a very recent phase 1 clinical trial done in SCA3 using this gene targeting strategy. And so this was a study run through Biogen, a major pharmaceutical company, initially just examining the safety and toxicity of using this drug. And unfortunately, just over a week ago, it was announced that this trial was stopped. And we still don't know the exact details of why this trial was stopped, but I thought it was important to bring up today because many of us are left in the community asking, well, how does this impact SCA1? What does it mean for SCA1? What does it mean for our other ataxias? And certainly this was disheartening, very disheartening news for those of us in the ataxia clinical and research community. But I don't want folks to lose hope. And so, for example, in early April, another company announced that they dosed their first genetic targeting strategy in a clinical trial that is for patients with Huntington's disease, SCA1, and SCA3. All three of those are CAG repeat expansion or polyQ or polyglutamine diseases. And this is an antisense oligonucleotide or a genetic therapy against that CAG repeat expansion itself. So many of us will be very curious to see how this clinical trial progresses and what the ramifications and impact of it are on the rest of our ataxia community. I told you that basic science, in my belief, will drive these new therapeutics. I myself spend much time thinking about ion channels and how they impact the cerebellum and how we can drug them to treat cerebellar ataxia. But if you even look at the NAF website and look at the therapies in development for SCA1, I want to show you that there's so many clinical trials and therapies being developed and advanced along the pipeline. So I hope this brings some optimism and hope into the community that just because one trial fails doesn't mean that we are stopping or that we won't try further or that something else may not work down the road. So looking at this slide gave me a lot of hope and made me feel really good about the direction of the ataxia community and the ataxia world. But one of my parting comments will be just as a general personal note, which is why target just one? And I think it's really important to think about these diseases as very complex, multifactorial diseases for which there are multiple targets. And so I think the future for SCA1 therapeutics and ataxia therapeutics is probably going to be doing combination therapies where maybe we target the genetic mutation along with one of these other downstream pathways. All right, so what can you do next as an ataxia patient or an ataxia family member? Really, I can't, I think this entire presentation was almost a pitch for the National Ataxia Foundation, which does such a tremendous job for the ataxia community and bringing resources and connecting patients to providers and research. I've highlighted two major clinical studies below here. ReadySCA on the right, which is a clinical trial readiness study for SCA1 and SCA3. That study is going to be wrapping up very shortly, but the Clinical Research Consortium for the Study of Cerebellar Ataxia, or CRC-SCA, is now an international group of institutions examining our ataxia patients, including SCA1, over time. And it's really important in these rare diseases to track patients over time with multiple data points. And that means things like myself as a neurologist examining a patient, jotting down a ataxia clinical rating scale, talking with the patient, what symptoms do you have? What bothers you the most? Talking with the caregiver, how does the patient do during the day? What are the activities that they struggle with? What about, fine motor skills, speech? And it's really important that we have a detailed characterization of how these diseases progress over time, so that when we have therapeutics available, even in these rare diseases, we'll be able to understand, does the disease shift the curve? And so I encourage you, if you haven't already, to reach out to the National Ataxia Foundation or to your provider about enrolling in one of these studies or finding out more information. And so with that, I will stop here and I will be happy to take any questions. I hope I've done justice to the SCA1 field, and I will stop there. And thank you for having me.
Well, thank you for such a fantastic talk. As someone who my research background is in SCA1 as well, thank you so much for putting together a fantastic talk. Just a reminder for folks that you can drop questions in the Q&A window at the bottom of your screen, and we already have a ton of them coming through, and we're going to get to as many as we can in the next 19 minutes or so.
Sure, I'm going to end my slideshow then.
Fantastic. And just before we jump into questions specifically for you, a number of people have been asking about two things. One, how do they find a neurologist? And two, how do they participate in that free genetic testing service offered by the National Ataxia Foundation? So we have some staff who are in the chat right now, and they're going to be dropping some links to help you direct to those resources through the National Ataxia Foundation. So let's jump into SCA1 specific questions. So the first is talking about CAG repeat numbers. So can your CAG repeat numbers change over time?
Yeah, that's an excellent question. And is one that Celeste and myself and many people in the ataxia research community are trying to answer. And so what is very clear to us is that CAG repeat numbers can change from generation to generation, and that phenomenon I described called anticipation. What is also clear to us is that different cells in the body may have different CAG repeat numbers. So even within the brain, the front of the brain may have a different CAG repeat number than the back of the brain. And that's a phenomenon that's called somatic instability or somatic repeat instability. What is less clear to researchers and to clinicians at this time is, within a single cell, in a single person, over the course of their lifetime, does that CAG repeat number change? And at least right now, the evidence would say no, but I think that's a very open question. I think it's a little bit difficult because in brain cells, for example, they don't divide and they are what we call post-mitotic, and they can mature and grow, but their DNA is not actively replicating or being changed, which usually means that the genes they have are going to remain the genes they are, even though expression patterns can change and changes to proteins can change over time. Hopefully that answered your question, but I'm happy to clarify if not.
Oh, that's fantastic. We now have a question about inheritance. So in the example you gave, it was the father who had SCA1. Does the chance of passing it on to your children differ if it's the father who has SCA1 or the mother who has SCA1?
Yeah, great question. So no, there is no difference if it is being passed on by the father or the mother. It's 50% no matter what. That's because the ataxin-1 gene is not on a sex chromosome. So it's not on the X or Y chromosome. So it doesn't matter the sex of the parent. It's passed on 50% of the time. What does seem to be clear is that that phenomenon of anticipation does seem to occur more when the father passes on the gene rather than when the mother. That just simply means that the child of an affected father is more likely to have worsening disease than if their mother was affected, but that's not 100%.
Still a lot to figure out on that. Our next question is about MRI imaging. So is the MRI imaging for SCA1 patients similar to other folks who have other kinds of spinocerebellar ataxias?
Yeah, like the answer to most medical questions, probably the answer is it depends. And that will be, it depends on which other SCA that's compared to. So SCA1 and SCA2, for example, have similar imaging findings. SCA3 has a slightly different imaging phenotype. SCA6 does not typically have brainstem involvement, for example. And so the imaging findings can look similar to some ataxias and different from many of the other ones.
Our next question is about the ataxin-1 protein. So since the mutation that causes SCA1 is present from the time you're born, why does it start impacting people when they're older? Is it something to do with metabolism, or is there something else impacting that?
This is a wonderful question. Celeste knows, and this is a question that has plagued the research community and the clinical community for decades. We are just starting to get hints at why that's the case. And we think that as we all age, there are the way our cells work and function declines over time. And we think that some of these age-related mechanisms that start declining with age contribute to the symptom onset in ataxia and work with the ataxin-1 protein to contribute to disease onset. So certainly metabolism may be part of it. Obviously, the CAG repeat number drives a lot of it. So people who have a very high number will present earlier in life. People who have a low number will present very much later in life. But it does seem to be related to age-dependent mechanisms, which we think relate to calcium handling and how our brain cells handle calcium.
Fantastic. Our next question is it possible for someone to have more than one type of spinocerebellar ataxia at the same time, like having the mutation for SCA1 and SCA3? And how rare would that be?
Yeah, it's absolutely possible. And the way that that would occur is if mom had SCA1 or dad had SCA1 and the other parents had SCA3. And each parent is at 50% risk of passing along the affected genes. So if mom had SCA1 and dad had SCA3, the child is at 50% risk of having each one. So 50% risk of SCA1 and 50% risk of SCA3 independently of each other. So it is very possible. There are case reports of people who are affected with multiple types of SCA. It's exceedingly rare. It's usually, these are rare diseases. So, it's unusual to find two people with an SCA who exist at all, and then to find them that they've married each other or had children together.
Another question and more about symptoms. Is restless leg syndrome common for folks who have SCA1?
Yeah, restless leg syndrome can absolutely be a common symptom for SCA1. I tend to think of it more for SCAs 2 and 3 as well, who develop a little bit more Parkinsonism than SCA1. But there's plenty of SCA1 patients who can have restless leg and other Parkinson symptoms. I think this is a good opportunity to comment that there is tremendous heterogeneity and variability in these diseases and how they present clinically. And there are people with SCA1 and SCA3 who clinically may look identical, but have two completely different diseases. And we have a very long way to go in understanding exactly why that's the case. And two people with SCA1, even with similar repeat numbers, may look very different. And we have a long way to try and understand what are the environmental or other genetic factors that may be modifying the ataxin-1 gene or ataxin-1 protein to change how clinical symptoms present. So when I give answers to how things are common or what's most likely, it's sort of based on convention and the statistics that we see, but it's important to understand that just because it's not common doesn't mean it can't happen.
Totally. And I'm just going to jump down the question list to a related question. When someone comes to visit you in the clinic, what kinds of activities do you have them do? How do you measure ataxia? Do you use things like the SARA scale?
Yeah, so I think the most important thing that I do with a person is, first of all, just sitting and talking with them and observing them. I tell the students and residents and fellows that I work with that my neurological examination starts the moment I walk in the room. And that's me paying attention to how do you perk up when you see that I've walked into the room? Do your eyes follow me when I move to walk down to sit next to you? How do you address me? How's your speech? Is it clear? Is it immediate in response? But then eventually I will go through detailed testing, including testing things like memory and attention, tracking eye movements, having them do tracking my finger, doing target practice with my finger to see how accurate are their eye movements, having them pronounce difficult phrases and really listen to how clear is their enunciation. Probably every neurologist will tell you that the most important thing you can do is watch somebody walk. And so that is usually the most informative part. I'll certainly ask patients to move their arms and move their legs and test how accurate and how fast and how strong they are. But I get a lot of information from watching somebody walk, and as best as they can without any sort of assistive device.
That's very helpful to know. Earlier in the talk, you mentioned describing episodes of ataxia. Could you explain a little bit more what you meant by that?
Yeah, so this is a phenomenon that we see in many of our neurodegenerative diseases. And so let me define neurodegenerative disease, which means that it's a chronic progressive disease without any reversal, and it will continue to progress over time. And usually that means that one part or multiple parts of the brain are dying off for reasons that we often do or don't understand. And so even though we talk about things as a very slow, gradual progression, many patients will say, I felt imbalanced or uncoordinated for a day, and then it went away and I didn't think anything of it. And then 2 weeks later, I had another episode where I felt uncoordinated for a couple of hours, and then it went away. But over time, they say, eventually those episodes started lasting longer or becoming more frequent. And eventually it becomes this constant sensation of clinical symptoms or of difficulty. And so that was kind of my what I was trying to describe by moving from an episodic to a more chronic ataxic symptom.
For our next question, we have someone who has their family. There's a couple of family members who have SCA1 who are diagnosed. Their question, one of their siblings has kids who are under the age of 18. Should they be tested right now for SCA1?
Another great question. So the answer is, if they're under the age of 18, currently we would not offer genetic testing to that person. The major reason for that is because it would not change management at this time, in the sense that there is no cure. At least that's how insurance companies and genetic testing companies view it. The real reason is because, during my presentation, I put up a slide about the complexities of genetic testing and understanding the reasons to do genetic testing and not to do genetic testing. And in general, young children have a real hard difficulty understanding that process and that thought process and consenting to genetic testing. And so in some cases, if there's an older teenager who can assent to testing, if they're 15, 16, 17, and really are an intelligent teenager who can vocalize, the thought process and that they understand the concepts, we might proceed with genetic testing, but in general, we wait to the age of 18 for that reason.
And then we have another sort of family related question. This attendee has a Q length that's in that undefined region that you were talking about earlier in the presentation. And their family members also have this undefined range, but their family members have started to get symptoms. Does that mean that they are more likely to develop symptoms as well?
So not necessarily. And so when you're in that indeterminate range, there are a couple of key questions. And so in Ataxin 1, it's CAG is the repeat expansion. But there's a fourth letter that's not part of that, which is the letter T. And sometimes you can have a CAT interruption or a change in the repeat. Instead, it'll go CAG, CAG, CAT, CAG, CAG, and then continue forward. And so we actually will count, when we're testing genetic sequencing, how many CAT interruptions there are in your repeat expansion. And the more number of CAT interruptions, actually, the lower likelihood of having symptoms or developing the disease. Whereas people in the indeterminate or intermediate range who have 0 CAT interruptions are more likely to have or develop symptoms. So your siblings, for example, could have fewer CAT interruptions than you do. Or similarly, I told you that there are genes outside of Ataxin 1 and changes in genes outside of Ataxin 1 that may be impacting. We also really still don't understand the environmental impacts and exposure impacts to how these genes work and disease onset. So I would say perhaps slightly increased risk from somebody else, but not necessarily absolutely going to get the symptoms.
We have another question about symptoms. How common is it to have psychological or cognitive symptoms for folks who have SCA1?
Yeah, so the incidence of, I guess, psychological or even psychiatric symptoms is higher in any person with neurological disease. And so all neurological diseases, regardless of the cause, carry a comorbidity of psychological or psychiatric disease. Depression, anxiety seem to be very common in patients with SCA or any type of ataxia. The cerebellum coordinates a lot of things, and we think it probably helps in the coordination of our thoughts and our moods and our cognitive function as well. So in SCA1, especially later in disease or people with really high repeat numbers, we actually can see some cognitive deficits that can look sort of like a dementia.
Awesome. Our next question is about treatments for SCA1. Uh, are the treatments for SCA1, could those, sorry, let me rephrase that. Can treatments for SCA3 be used for SCA1 patients effectively, or is it only based on the type of ataxia that you have?
Great question. So currently there is no treatment for any type of SCA. The FDA just a few weeks ago approved the first treatment for any type of ataxia, which was a drug for Friedreich's ataxia, which is typically childhood in onset. The only therapeutics currently that are being developed that are in theory unique to each SCA would be the genes targeting strategies. So a therapeutic that targets the SCA3 causing gene could not be used for SCA1 and vice versa. However, a lot of these SCAs share common pathological hallmarks or share dysfunction in cell pathways. And so therapies that target those shared mechanisms could absolutely be used across SCAs. And I do that frequently with many of my patients are on the same drugs because their SCAs, even though they're different, share very similar mechanisms.
And just to follow up on that, for some of maybe the supportive strategies that are available right now, like PT, OT, speech pathology, does that need to be customized to the type of ataxia you have, or is that a little bit more common across ataxia types?
I would say that in an ideal world, yes, it should be customized because I think it should be customized to each person. And this goes back to not just necessarily each ataxia, because there's variability and heterogeneity. And you could have one SCA1 patient who looks different than another SCA1 patient, but similar to an SCA3 patient. And I think it gets really difficult to decide how to customize therapy to a disease, but rather to a person. And when you go and visit with either a PT, OT, or SLP, the first thing they'll do is an intake where they will watch you walk or use your hands or speak to them and try identify what are the things that you as an individual are struggling with that, and then develop targeted strategies to help you with your weaknesses or the things that you need help with. I think that a therapist, whether that is versed in neurological diseases and ideally has seen some ataxia patients, would be very equipped to do that sort of thing.
Great. And with the last minute I think we have time for one last question. We have an attendee who's really loves the talk and is interested in learning more about ongoing research and clinical trials with SCA1. Where would you recommend they find out more information?
Yeah, so this is the best place to go, which is the National Ataxia Foundation website. I can't tell if they put it in the chat, but there is a link in the NAF website to ongoing clinical trials by each type of SCA. And you can click the SCA1 option. It will bring you to the website that had the graphic I showed in my talk on the drug discovery pipeline and where different drugs are in the pipeline. And then there's links with more information about each of those therapeutics that you can click. Some of them will take you outside. You can also go to clinicaltrials.gov, which is the US clinical trials database. And then you can type in Spinocerebellar Ataxia type 1. And even you can do it by map. And so you can say what clinical trials in SCA1 closest to me are available. And so you could find out about ongoing clinical trials and then contact the coordinators to see if you're eligible to participate.
And with that, we are out of time. So if everyone could join me individually at your own screens, thanking our speaker today for sharing with us some fantastic information about SCA1. Thank you all so much for joining us today. I hope that you found this talk valuable and engaging, and have a wonderful rest of your day or evening, depending on where you are in the world. Bye, folks.
Thank you for joining us.